So welcome, everyone. My name is Robby Greenfield. I'm a co-creator of ConsenSys Social Impact and also a blockchain engineer. So I go to and from BizDev and engineering and coding. More coding recently, which has been great. And because of my peculiar situation dealing in social impact, I have the utmost user constraints. So there are a lot of things that we'll walk through. We'll start from the use case, and then we'll go all the way down to the tech, and probably cover some things that you all may already know, some resources that hopefully are new to you, and all in an effort really to make your UX better, particularly for vulnerable populations that aren't going to have the luxury of using MetaMask or Brave or whichever, even though I love both of those. So a little bit about what blockchain for social impact is, what ConsenSys social impact is. So this is a recently new advent to the horde of companies within ConsenSys. But basically, we are a research and development firm that assist and partner with NGOs, governments, and other organizations to focus on directly socially impactful projects. We do this in a multitude of ways, and we kind of switch between a lot of verticals, whether it be self-sovereign identity, whether it be financial innovation, and a host of many, many more things. But oftentimes, the most functional products that we kind of devise, whether by ourselves or with our partners or through our kind of crypto-economic structures in terms of research, tend to be pretty simple. And that's actually a good thing. So today, we're going to go through immutable reporting, the most basic of use cases, and how that use case alone can be a tangible solution for a lot of organizations out there doing great work. We're going to go through the transaction lifecycle, something that even up to very recently I thought I understood, and I know many of us probably think we understood, but I took another look at, and really understanding that and taking yourself away from the easiness that Truffle gives us when it comes to developing is extremely important, because we don't realize the flexibility that we lose when we gain the convenience of using a Truffle in our Dapp architecture. And the last is hybridized fee forwarding. So how can we use hybridized solutions? In order to scale, in order to gain mainstream users, you are going to need to use a hybrid approach, period. Many of us know this because things aren't currently scalable, whether it comes to throughput, transactional throughput on Ethereum, or just storage constraints on IPFS, and a whole host of user constraints that come with that when you're trying to build this decentralized experience for your users. And the other side, I just couldn't come up with anything, so I just put blockchain basics. Evens the slide out very nicely. Starting with the use cases, we're going to talk about war crime evidence and sexual assault reporting. The latter is actually very, very, very native to the Bay Area. We'll actually talk about a use case that we're doing within the Bay Area, compare it to the current situation, and show you how both of these use cases, although the content is very different, what they're trying to do is exactly the same. And their user constraints are exactly the same. So, war crime evidence. To give you a little bit of a background, typically war crime evidence is very difficult to acquire. And usually it's very dangerous to acquire, and it's either volunteers or censors that are going to be recording anything. And even when you do that, the time that it takes to submit that evidence to International Criminal Court and come to a verdict, a guilty verdict, on whichever regime, terrorist group, organization, state is guilty, it takes a very long time. And in between that time, particularly those who are journalists, their lives can be threatened, unfortunately taken away, and many other things can happen, and the evidence can be tampered with. In fact, many times the evidence is just completely destroyed. So it's very difficult for organizations working in this space to try to bring justice to these different areas to maintain what is seen as valid evidence, because they can keep it in a journal on AWS, but if it's only on their database structure and we don't see it, and then they bring it out into criminal court, we can't reasonably say that it's been tampered with or not. even though that organization probably is extremely upstanding. The second is, so this picture actually came up when I Googled sexual assault. Very fitting. I don't know why it's in black and white, but so sexual assault is also a huge issue. So right now in Oakland, if you're sexually assaulted and you self-report, the process is that you write it down and then you fax the district attorney's office, which is freaking ridiculous in 2018. Obviously, with this process, you have illegibility because someone writing something as traumatic as a sexual assault, probably not in the best mind state to be writing and faxing something. And also the lead time in terms of the response of different support services and legal services is super, super slow. So this is a huge issue, and it requires the same immutability, that you want to have proof not only for the person that they made that report, but also for accountability practices for everyone else to be able to see, pseudonymously or anonymously, that this report was made and that it hasn't been enacted on. Extremely important process, and we're working with an organization that's digitizing this process. So the use case in terms of the solution that we'll show relates to how we can get around this as well. Again, you're dealing with a vulnerable population that does not want to hodl ETH, does not want to download MetaMask to submit their report, right? They just want to do something very simple. So what do these use cases demand? And this is, I don't do much slide reading, but this is like extremely important, especially for the devs. So both use cases have traditional systems. And more on this point, when you're creating your development roadmap, you need to make sure that some aspect of your solution can integrate with traditional architecture. That isn't to say that we want to give centralized systems a chance to mature and develop along with what's being created in the Ethereum ecosystem. That's to say that you're going to get the most mainstream users and you're going to solve the most problems if people can interface with your technology more scalably. And they just cannot do that in the current way that things are. Both use cases have a valid blockchain use case, right? So I don't really need to go much into this, but making sure that things are blockchain valid, right? So in both cases, we want to immutably store something and have reference for it, and probably do a checksum, in terms of comparing it to see if it's valid or not. And the last two are both use cases cannot afford to disrupt the user experience. Again, paying transaction fees in particular is something that is completely disrupting the Dapp UX. And honestly, things like CryptoKitties, I mean, we see it as amazing because it introduced a large part of the mainstream world into dApps. But what they did, utilizing MetaMask, is even more amazing. That shows you how much kind of gravitational pull that product had to have people download MetaMask, figure out what the heck it is. And actually, talking with the MetaMask team, a lot of people using CryptoKitties thought that MetaMask was part of CryptoKitties. So they were emailing the MetaMask team saying, why are you taking so much gas? Well, where are the fees going? And like, no, that goes to Ethereum. What is Ethereum? It's like, no. So it's crucial that we don't impose some of the things that we love very dearly in terms of the technical stuff, the crypto economics, to those who really just want to use our applications. And the last thing, again, both application architectures can't simply just decentralize, right? Particularly when you're dealing with the social sector, public services. A lot of these organizations could just use a website and their efficiency would go up 200%. And there's a reason that they haven't made that transition, because their team subject matter expertise focuses on the people, right? They don't have dedicated software engineers. They don't have people who really focus on that. And if they do, it's usually an IT department dedicated to every department across the organization, and they're usually stretched very thin. So you have to create that roadmap both for yourself as a solution architect, but also for that organization to how do we take metered steps from a centralized traditional architecture to something that's more decentralized, and hopefully in a few years is completely decentralized. So transaction lifecycle. This is super exciting because if you've been like using the crap out of Drizzle, you know that you just download that box, right? And you got this contract form, and it has the button already in it, and the little styling issues a little bit. But you press amount to send, and you're good to go. The transaction is done, right? And there are some great things about this, and there's some bad things about this. The great thing is that doing this before, I don't know if you all started developing a year ago, but like migrating to testnet and mainnet a year ago was hard. That was like you're doing a sprint on just migrating. And now it's fairly simple, right? You can do a few workarounds. You can use Remix, deploy your smart contracts on Remix IDE, right? And then, just reference the ABI and the address, and you're pretty much good to go. But the issue with this is that when you want to do more creative things other than just show data or submit a form, you're going to encounter some problems. And this even encounters problems because if you use the contract data, right, when showing data, you have that query time. Because querying the blockchain sucks. Super slow. And this is where hybrid architectures are going to help you, right? You want to have that catch of data of what's in that transaction. So for the user experience, they see what they need to see. They don't need to wait for 18 spinning circles for every contract data template that you have on your site. And that's crucial. So a real Dapp transaction lifecycle follows this process. You're going to create a raw transaction object, and setting things like gas price, gas limit, and your data payload aren't as self-explanatory as you would think, particularly when you want to make sure that your architecture can work across networks, right? Otherwise, you're hard coding, different network addresses or your Infura key and all this other type of stuff. So you want to make sure that with any API response, if you indicate which network, all of those variables are going to change accordingly. Two, not necessarily self-explanatory, but the two for a raw transaction, if you want to equivocate it to what we just saw there, is going to be the smart contract address. And that's not necessarily self-explanatory either. Signing the raw transaction. So there are many ways to sign a raw transaction, and there are a lot of ways that are deprecating. So each sign is deprecating. So what's the best way to sign and serialize your transaction? But that's not too hard, right? We're all devs. We can Stack Overflow that. And transaction validated by local Ethereum node, that's always going to be Infura. Props to the Infura team. And then transaction paid for and broadcasted to the network. So another thing in terms of send raw transaction is just making sure that you catch errors. I know that this is self-explanatory to many of you, but oftentimes if your transaction fails and all of these variables are set and are like reasonable, you're not going to get anything from send raw transaction. In fact, in some cases, you will get a transaction hash and be wondering, why can't I look on this on Etherscan? I did this like 50 times, and I was like, I don't know why I'm getting a transaction hash, but nothing is on Etherscan. So again, we're going to go into kind of creating data payloads, so maintaining access to the ABI, which I think even right now, like keeping ABI JSON on your Dapp architecture is kind of annoying. Getting the function signature hash, which is a trial. Now, in Web 3.js 1.0, the beta, there are methods to attend to this. But creating the data payload, right, those inputs that you're sending to your smart contract function is not fun. It's just not fun. Especially if you didn't know that methods exist, and you're like trying to do this literally like you were like parsing a string or something. And then converting input to byte 32 and concatenating results. Coding the details, again, making sure that everything's valid. Nonces for smart contracts is the number of transactions sent to that smart contract, right? So the definition kind of changes for a nonce, everyone pronounce it, for smart contracts. And then dynamically estimating gas limit and price. Again, needs to be network dynamic. So some code, all right. So I Googled this for like many hours, right? I feel like that's like 40% of being a developer. And one thing that I found that was really interesting was the solidity function. And you have to call it, you can tell it's hidden because you have to like do web3/lib/web3/function. It doesn't just naturally kind of come off of the Web3 instance. And I was like, why? So this is the secret sauce right here, all right? So this does a lot of what I was talking about. And the reason why you're going to want to do this, guys, is because this makes your application more dynamic. Now you're starting about, OK, if we create an API service that encompasses this code, we can now have users submit normal input, right, that goes to the API and submits the transaction for them. That does two things. One, they no longer have to download MetaMask, right, because they don't need to sign the transaction on their browser. The second thing is it pays for their transaction fees, which is huge. You have to pay for your users' transaction fees. Unless you're a crypto economic system that involves tokens, right? So a natural part of interacting, like a TCR, for example, a natural part of interacting with the system deals with a token. If it's just like a simple button press, right, that doesn't really have any belabored secondary effects, you should be paying for their gas. And Solidity function both gets your function signature, which is just long string, and it hashes it, and then it also converts those imports to bytes 32 and creates your payload for you. So with those two lines of code, you're pretty much set to go. So definitely check out Solidity function, and that is the path for it. Now, another thing in terms of dynamic multi-network Web3.js, shout out to Uport. This is Uport's code. And we'll go into some open source things that we worked on Uport with that you all should access. Is just making sure that your network's config file has all your Infura stuff on there. Of course, the key you probably want to encrypt. But making sure that you can reference in your code, you can switch the network out whenever. So that, again, in the context of an API, whatever is sending that response should be identifying which network it wants to work on. And then because of that, right, you're automatically setting your gas limits, you're estimating your gas price. All that stuff is relevant to the network that you're working on. And then setting a default gas price never hurts. It'll reset. So finally, hybrid solutions, Sensui and Sensui mod. So show of hands, anyone familiar with Sensui who's not on the MetaMask team? Dope! OK. Oh, shit. All right. So that's really exciting. So a part of the Uport architecture, the reason, who's used Uport? Who's downloaded and used Uport? So a few of you. So the reason why you do not need to pay your transaction fees on Uport is because of the Sensui service, which is a transaction fee paying and forwarding service that Uport created. This wasn't until very recently made public. So if you go on GitHub and you type in Lambda Sensui, it is public for your use. We put hella documentation on it. And then our team also created Sensui mod, which is just a modified version of Sensui because there are a few more user constraints that the social impact team needs to attend to that Sensui doesn't necessarily attend to. So it's made with Lambda and serverless, pays for transaction fees, and basically the flow is that your Dapp can create any meta transaction, right? And you can still use a MetaMask with the normal Sensui, and in fact, you should. And all your user is going to do, right? They press that button, right? That's going to initiate their transaction. All they need to do is sign it, right? So zero cost, $0, 0 ETH, 0 gas. And that meta transaction is sent to the Sensui service, right? That recreates the transaction and then signs it itself and sends it as a raw transaction and pays for it. So Sensui forwards that meta transaction and pays for the transaction. Now, you're probably thinking you can DDoS the hell out of this, right? And you just send a whole bunch of BS meta transactions, and you can completely drain the server's wallet. Those are captured, in the flow of Sensui. So Uport did a really good job of making sure that people aren't setting the gas price way high. But I'm certain that you all could fork this and add additional security methods. Another thing is that this is not a long-term solution, right? I don't know, based on how we're going to scale and based on how different solutions, that are either coming in the Ethereum updates or are coming on off-chain payment channel updates, we may or may not have to accept that paying transaction fees on behalf of users is just an operational cost, just like using AWS or whatever. That just may be a reality that we need to come to. Now, if we come to it, it motivates us, right, to make things more scalable so that we can lower our costs. So the only difference between Sensui and Sensui Mod is that Sensui Mod takes normal input. So we're not forwarding a meta transaction, we're just getting normal input. So what this would mean is if we're submitting a form, this person doesn't even need MetaMask. They don't need to sign anything. All transactions are signed by the server. Now, granted, it's not the best because you kind of lose that pseudo-anonymous identity associated with the user, but there are other ways to cover that. And this is where we start to hybridize and take some of the lows of the decentralized experience and some of the highs of the centralized experience to make sure that we are solving the problem that we are set to solve, which is to get this on the Ethereum blockchain and have it as a third-party reference for immutable evidence and for sexual assault reports. It's kind of nice, not to have to, have a MetaMask or Brave always a part of your solution because it's just simply not an option for vulnerable populations. It's just not. Not at this time, but I'm certain those teams, particularly MetaMask, will come up with new ways in which it will be in this soon. And these are the system components. Shout out to Carmen, intern, blockchain intern, somewhere out right there. Hey, so this is her slide. I stole it. These are the components that you're going to be using. Authentication API is another good way to kind of meter usage, right? So again, it needs to be somebody who has a JSON web token to be able to even, submit their transactions. So this would usually submit a token and whatever input to the Sensui or Sensui mod service, and from there, things can get cracking. Also, for Sensui mod, we have the smart contract API. For normal Sensui, that's not needed, right? Because you already have a signed meta transaction being sent. But for Sensui mod, you do need to reference the API on your service because it needs to know which contract you're talking about. So this is kind of the architecture that we have here. So going from client-side applications to serverless stuff. And guys, if you all haven't used serverless before in terms of developing your API, certainly do so. It's freaking amazing. And Ethereum right there. So basically, in this architecture, we are using the database as a cache, right, so that we can serve that data on the UX faster. But all it's doing is it's saving the transactions that the blockchain's already saving. But again, we know that querying the blockchain is slow. So that's why we're using our database. And then you can have whatever dashboards or things like that. But also, for IoT devices, it makes that simpler as well, right? Because now you can just have the IoT device report whatever data that it was already reporting to this API in normal input form and know that that transaction is going to be submitted on the blockchain. Whether it goes through or not depends on if another CryptoKitties update comes out during the same time as the response. So, and that is it. Cool. Any questions?